Good morning. Since I can't be in school on Friday morning to share these tips and insight with you, I'd like to give you some direction for Model Exam 2, particularly Section 2, with our free response problems and practice. Here we go. I'm going to try to give you some reminders about what things should look like and where to find reference points in your book. For problem number 1, with the data that you're presented with, what you need to do is create the cumulative relative frequency plot. Now, a cumulative relative frequency plot came into play in, I believe, Chapter 1. And in a cumulative plot, what you're going to do is plot the number of accidents. This is cumulative frequency, number of accidents versus the cumulative frequency. Now that count for 0 accidents would be 6. The cumulative count for 1 accident would actually be 16, because we're really in a cumulative count saying it's 1 or less. And then there was 14 here, so the cumulative count would be 30 in that instance, and so on. So a frequency plot is going to be, and you can grab graph paper and plot this, it's going to be the number of accidents versus that cumulative frequency. And then you're going to get a nice connect your points and something to the effect of this, and then answer some questions about it. Again, I would suggest going back into Chapter 1 for that. In number 2, we've discussed at length simulation problems, and what I would like to remind you of is that in designing a simulation, we need to go through the process of labeling. How are we going to assign digits to represent the 6 different characters? How are we going to use the values in the table? Make sure that you're clear about that. And then actually conducting your simulation using the table. There's some details about the simulation and a change that's made, and then another follow-up with simulating again. So make sure you follow through on both of those. Our simulation techniques came up in Chapter 5. When you look at number 3, problem number 3 is about conducting a significance test. And what we know is, in this case, that we have a 5% level of significance. And from what I read, I believe that we're dealing with a mu of the 45,982, sampling 5 households. Boy, I'm a little hesitant about that because that's a small sample size. Curious if you can draw some conclusions about that sample condition. And we're dealing with an X bar of the 47,000, and that sample gave us an S of the 12,000. So you have a significance test. We've covered this type. Use your calculator. A confidence interval. Make sure that you interpret your confidence interval as well in the context of the problem. And then answering the last part, C. Is it consistent with what we expected? So basically in C, you need to say, is the mu contained in your confidence interval? Now number 4, I would like you to, on number 4, refer back to Chapter 3. And I'd like you to focus only on 4A. We will discuss in class how our calculator can transform data. These are new concepts that we did not study in Chapter 4 when they came up, and that's quite all right. I want you to be prepared. Keep this data in your list if you can. If you want to go bury it in list 5, list 6, that would be perfectly fine, and then we can move it over when we talk about this when we come back after spring break. In number 5, you're dealing with a normal distribution. In number 5, you should be calculating z-scores using your standard normal table in order to answer the questions that you're given. Now, the last problem you have is a big one. This section 2 is, you see the recommendation there that you take a half an hour on this problem, and the recommendation for the others is just about as much time. So this one is a biggie. Lots going on in this problem, and I just want to share with you some things that I'll be looking for. In number 6A, I'm sorry, this is number 6, in part A, please be sure to have a hand-drawn scatter plot for this data. You're welcome to use your calculator to sketch it, but please go through and do a hand-drawn scatter plot, and your X is going to be the course value and your Y, the course grade, and then the Y is going to be the corresponding AP grade. So it's going to be an interesting scatter plot once you make it, actually, because the course grade has no limits on what the values can be, but the AP grade is going to be only whole numbers. And so what you'll see once you set this up, and I don't want you to be distracted by it, is, you know, something like this where you see kind of steps of scores, and that's because it's going to go along with, well, there's going to be like 5 of them. It goes along with the potential scores on the AP. Now, this is all Chapter 3, determine the correlation coefficient in the regression line. So this is our R correlation, and our regression line was Y hat equals AX plus B. And you can use your calculator for that. Again, this goes back into Chapter 3. The residual plot is the residual plot that you're going to have to create is actually your course value and the residual. Now remember, the residual has to do with taking the predicted Y and using the equation and comparing it to what we actually have what score we actually have that goes along with its corresponding X. The S standard error will come up in your calculator. Look into your book how to do that. And then actually we have not studied our hypothesis test on correlation. So you're going to struggle to find a test statistic unless you go into your calculator and choose the right test and come up with something. I think actually if you play around you might be able to come up with something there. Again, this is nonlinear model. This is like the last problem that I said we hadn't studied this. We'll talk about whether or not we want to conduct a transformation and what that looks like when we come back after break. Good luck.